So my name is Isaakidis. I'm a PhD student at University College London under the supervision of George Danezis, who is also co-authoring the paper. And in this hot patch talk, I mean, if you had enough of caffeine, then we can bring back to the discussion anonymous peer-to-peer storage networks and how they can be used for developing privacy-enhancing technologies. So, as privacy-enhancing technology developers, we need sometimes to provide network-level anonymity for our services. For example, if you would like to hide the user IP identifiers from the server, or hide the server IP in general from everybody, or hide that the whole communication has ever taken place. And the easy way is not to build all those things by ourselves. And we rely on low latency anonymity networks, such as the Tor, that provides the Onion services, and the internet, the Invisible Internet project, the I2P, so that we can route traffic to a hidden server somewhere anonymously in the network. So these types of networks, the low latency anonymity networks, they support routing traffic to a hidden server. We do not need to modify the logic of our software. We can use the same web servers. We can use the same messaging applications. And therefore, they can support the dominant architecture of the internet, the client-server model. However, this Tor-Swiss Army knife approach, to cite Brian Ford from Eclipse this Monday, comes with some caveats. Developers who build privacy-enhancing technologies on top of Tor or I2P, they have to, first of all, consider how this service is going to scale. We know of only very few examples that have managed to scale their applications, Facebook being one of them. And availability of the service, if one day I shut down my computer, then the service will not be available anymore, or if I have connectivity issues. And observability, if I could only highlight the importance of this enough for privacy-enhancing technologies. I would, of course, for example, as a whistleblowing platform developer, I would never want anyone to know about who is communicating with whom. And we know of timing attacks and traffic analysis attacks that they pose dangers to these networks. And how many darknets we know or that have been compromised because of PHP vulnerabilities and other platform security issues. So taking into consideration all those problems, we said, okay, why don't we, what are the alternatives? What can we do differently? What can we do? And we decided to experiment with the Freenet network, which is another anonymity network. It's a peer-to-peer storage network or anonymous publishing network. And we built a service called CNO, Censorship No, in collaboration with Equality in Canada. And it's a censorship circumvention service, providing some different properties. The basic functionality can be split into categories. We first preemptively insert and cache news websites, so people can anonymously retrieve them from the distributed storage. And we've also built a communication mechanism that users can anonymously again use in order to request from our insertion nodes to insert some websites for them. Let me take you now through the building blocks of our CNO service. Anonymous peer-to-peer storage networks. They first appeared some 15, 16 years ago, in the early 2000s, with FreeHaven, Dossier Store, and Freenet, and Publius being one of them. And as the name suggests, they are decentralized information storage and retrieval systems where nodes, first of all, provide the infrastructure, provide resources in terms of bandwidth and storage, so that we can have the service going up and running. And they cooperate as equal peers in replicating the files and routing the requests in the network. However, unlike the low latency anonymity networks, they cannot route traffic to a hidden server in the network. They provide only two very basic abstractions, insertions and retrievals. On the other side, they provide very strong security guarantees. Freenet, for example, assures the anonymity for both the producers and the consumers of information. And with plausible deniability, I could, if in case my computer gets seized, I can plausibly deny of knowing of what content is stored in my cache. The content inserted, so also Freenet assures the high availability and persistence of the information inserted, because inserted files get replicated. And even if I shut down my computer, lookups for my resources will still be successful because of being served by other nodes in the system. And if anyone would like to delete a file from the Freenet network, they would have to go to each of those nodes and remove it. Therefore, we have the property of censorship resistance. Again, I'm going to highlight again the global adversary resistance and the unobservability that those kind of networks they can provide, because their traffic looks like random UDP noise and is consistent. It doesn't open a window for timing attacks, for example. And given only those two very basic abstractions, what can be built actually on top of such networks? Let's go through what already exists there. In the beginning, people started building communication applications. So we have the Frost bulletin board, a forum, which also helped with announcing content that is being inserted. So if I wanted other people to find out about what I have published, I could make a post in the Frost bulletin board. Freemail is an email-like service that doesn't leak metadata. And the Flip IRC is an experiment with synchronous messaging. However, it experienced very long delays, and it suggested that this synchronous messaging doesn't fit very well the concept of caching networks. Later on, we got some collaboration applications like wiki systems and source code management systems. These are platforms that empower truly anonymous collaboration. And they exploit very well this self-caching and self-revisioning property of Freenet-like networks. What I would like to highlight here is that there have been some approaches towards client-server architecture applications on top of Freenet, with the library being the most prominent one, which is a distributed search engine. However, the maintainers crawl the websites and publish the indexes in the distributed storage, and they do not get direct requests from users in order to do the term matching themselves. Users retrieve the indexes and process them locally. So the term matching is happening locally, and the published indexes are there for everyone to download and use them. Now, if you would like to build a social aware application, Freenet has you covered. Using public key cryptography, there is a type of abstraction that lets only the owner of the private key to insert and update information, and others to discover what the owner has inserted. Therefore, for example, we can have services like Zone, which is a Twitter-like service on top of Freenet. And if this sounds something that it can be very easily spammed, it is. Therefore, the Web of Trust safeguard is a spam-resistant mechanism inspired by Revien's attack-resistant trust metrics. We are describing more about that in our paper. I don't have the time to talk about it now, sorry. Back to our service, Sino. I promise that it's a scalable application, something that it can handle properly lots of users. But if we want it to be a scalable application, we won't be able to deploy only a single node and have all the users communicating with it and doing all the insertion in one node. So what you see here is a deployment topology diagram of the Sino different types of nodes, because in networks like Freenet, scaling comes to, in the end, how well can you decouple the various tasks and allocate them to different types of nodes. So here you can see, for example, that the blue node is the tunnel creator that is accepting requests to create anonymous communication channels with our nodes. And then the inserter, for example, the green nodes are inserting content. And of course, you see that all of our nodes are Freenet nodes, and they are connected to other Freenet nodes. They don't differ in any way, but they are also running our new plugins. And what I would like to draw, I would like to draw your attention to those yellow nodes, the backbone nodes. These are very different to the Ethernet backbone nodes. They are actually Freenet nodes that we control, and they are dispersed in the Freenet network. And the only difference is that they are given higher bandwidth and storage limits. And they are connected, all our nodes are connected using high trust links. So in these links, the speed of the requests is going much faster, and we also have the capability of sending directly node-to-node messages. We can have, for example, direct messages going from the channel creator to the request handler, etc. These backbone nodes, nevertheless, they speed up Sino in general. They hide our nodes' IPs from the rest of the network, as you can see. None of our important nodes is connected to any other Freenet node, and they improve the availability of our content. So, was the idea of building Sino, a censorship circumvention service, over Freenet a good one? Well, first of all, we do not need to publish any proxies and bridges addresses, taking Sino to the era beyond the cat and mouse game. And what we are creating is a self-version of the Internet Archive, so you can take a look, for example, and what the BBC News has published today and what they published a week ago. The messaging mechanism that we build is quite efficient compared to what already exists and provide very strong guarantees. Again, you can take a look at our GitHub repository. And what's weird, but it's happening with all caching applications, is that once the request has been handled and the resource is in the distributed storage, then subsequent requests do not need to go to the bridges, insertion nodes, all these things. They can get served directly via the distributed storage. Also, very important for censorship circumvention is that if a country decides to throttle internet access to the rest of the world, if a resource is cached in a node within the country, it will still be available to the rest of the people there. And this leads us to the Sino paradox, which says Sino and any caching application becomes faster and requires fewer resources, fewer request handling nodes, as it gets widely adopted. Because the probability of a URL, of a website being already cached is higher, and because the respective resources get better replicated in the network. Now, in general, if you're a bit convinced of using Freenet as an anonymity service or an anonymity platform, it provides very good APIs for developing plugins and a community that they will help you a lot throughout the process. And the existing user base assures the anonymity of your users and provides storage capacity for you to start inserting your content. Nevertheless, you won't have to build all the security properties of Freenet from scratch. They've been out there in development for the last 15 years. Finally, I am highlighting again the resistance to traffic analysis attacks. If you are building a whistleblowing platform, consider Freenet as a system for it. I mean, we've seen how it can scale. We've seen other type of applications that have been developed, and we know how to do it. On the other side, it's not a unicorn. It comes again with open challenges. Caching networks, they cannot provide efficiently dynamic content, and synchronous messaging is something that we have many times tried to do and we failed. And these two aforementioned properties are affecting the performance of our systems. Requesting a website from Freenet that is already cached there takes around 2 minutes, but if we would like to request a website to be inserted for us by communicating an inserter node, that would take around 50 minutes to an hour. Content that is unpopular, that is not retrieved by many users, eventually gets overwritten by new content, which could also affect your services. And Freenet is a decentralized system, so as in every system, we have the problem of spamming. And if you would like to scale your applications, you would have to put a special thought on how to do that. So this is what I would like to actually propose with this talk, is that if you are building a privacy enhancing application, maybe you should consider also the alternatives to Tor and I2P. Systems like Freenet and other anonymous peer-to-peer storage networks could provide better properties to your systems depending on its case. You can find all the source code in our GitHub repository in Equality. Equality is also hiring a lead developer for Sino version 2, which will also combine the properties of caching with low latency anonymity mixing. So we are looking for a lead developer to take on with this task. Come find me, or graphic lunar kid over there. And yeah, questions please.